Hi everyone, welcome back to the another exciting videos, and we are continuing the low level design series. If you haven't checked out the series, you can go to the channel page and you can check it out full LLD series. In this video, we are starting with the first behavioral pattern, which is the observer pattern. Okay. So we will implement the observer pattern. We will go through all the theories, concepts, why we need it, what are the pros and cons, and how to implement that in the real life, and which are the scenarios in that you can implement the observer pattern. So we will deep dive into the observer pattern. So let's start with this video. Now let's start with the observer pattern. Observer pattern is a behavioral design pattern in system design. It is very common and very popular design pattern. Okay. So it solves a lot of problem which is very common in our daily life, like sending notification to multiple channels. Okay. And one event needs to be listened by many other servers. Okay. So these kind of scenarios, we need to implement the observer pattern. Now let's take a problem statement. Suppose we have a weather station, okay, and this weather station captures the temperature via temperature sensor or something like that. And this temperature needs to be sent to multiple devices. Okay, let's say multiple device display devices are there. Whenever the temperature changes, then it needs to be sent to the mobile, tablet, smart TV, and other, let's say, another devices also. So without observer pattern, what we need to do? Weather station directly calls every device, which is very complicated. And if let's say in future a new device comes, okay, then we need to add it to this weather station, and then it will send to the then the weather station will send this temperature to the other device. That is very complicated. Now, let's say we don't have the observer pattern. Okay, then we need to do the tight coupling. And if we want to scale, okay, this code, then it will be difficult. And if we want to maintain this code, okay, then it would be hard and it violates the open closed principle. Why? Because let's say the weather station, okay, this weather station is directly dependent on the mobile display or the other things. Okay, so that should not be the case. Also, adding the new device requires modifying the existing code, which is very bad. What do we actually need? We need one source of data, like the centralized metric engine, okay, that will capture the temperature or something data. Then we will have the multiple subscriber. Okay, then it should be dynamic also. Okay, the one subscriber can add themselves or remove themselves. Okay, then it should be automatic notification. This weather station should not know like to whom it is sending. Okay, it should just capture the temperature, and other things should be automatic. And other thing is loose coupling. Okay, the weather station should not depend on the other devices, display devices. It should just only capture the temperature only. Zero hard tracking knowledge. Now let's see what is the observer pattern. It defines a one-to-many dependency between objects, so that when one object changes state, all dependents are notified automatically. So that is the observer pattern. Let's say we are having this subject, which is weather station in our case. It will have the add observer, like add display device, remove display device, or remove the observer, and notify the observers. And these are the observers. Okay, that may be many more or less. Okay, now this is the interface of the subject, which is the add observer. It will take an observer. It will remove observer, which will take also an observer, and notify observers, which will notify all the observers. And this is the observer interface. What observer will do? Observer will take the information from the weather station or these subject, and it will update their own devices or wherever it needs to be updated. It will take the temperature. Next, the weather station implementation. Okay, that we will do in our IntelliJ idea. Okay, this is for the reference only. You can go through it. Now let's implement the weather station. Okay, in this weather station, we will have the interface. Okay, which will be, let's say, subject. And in the subject, what we need to add, as you know, we will have the void add observer. If you take observer, remove observer, which will take also the observer, and we will have the void notify observer. Okay, now we will also have the interfaces observer. Okay, this observer will have the update method, and which will take the let's say in temperature, which it needs to be updated. Now let's implement the weather station. Now we will have the weather station actual class, which will implement the subject. Now this weather station, what it will have the observer, not the observer, like list of the observers, correct? And this add observer, what it will do, it will observers, so add observer, and what it will do, remove, or what it will do, will remove the observer, and the notify observers, what it will do, it will notify all the observers. Let's say observer owing observers, o dot notify, we have the o dot update, correct? And we need to send the temperature, which we need to make a private temperature. So this is the implementation of the weather station. Okay. See, now we will have the multiple display devices. Okay. So let's create some display devices. Let's say mobile display, which implements the observer, correct? And we need to implement this update method over here. And this mobile display will have this separate implementation of the updating their temperature by their own. Okay, we are just printing the temperature in the mobile. Okay, we'll say mobile temp. We will have the temp, correct? And let's say we will have the TV display, correct? Which will also implement the observer, correct? So what it will do, it will just simply say TV temperature, right? Now let's go to the main class where we will create this actual weather station. We will have the main method over here, and what we will say, we'll say weather station. Weather station is new weather station, correct? And let's create some observer mobile, new mobile display, and let's say observer TV is new TV display. And now what we'll do, we'll say weather station dot uh, add observer. What is the observer? Let's say we want to add the mobile, and simply we will say the let's add the TV also. Now we'll say station dot set temperature. Okay. Now we are not setting this temperature. We don't have this set temperature na in the weather station. Let's implement that one setter for this temperature. Generate. We need to setter and for the temperature only. And after the setting this temperature, we will say notify observers. We will call this notify observers. Now let's go to the main class and we'll say set temperature to 10. Okay. And just it will notify all the observers automatically. Let's run this. Let's update it to the 12. Okay. It is saying like TV temperature is 10, then mobile temperature, then TV temperature. Okay. See temperature tab, and this is when you add a new display device or remove a new display device. Correct. So this is the benefit of observer pattern. We don't need to mobile and tab, TV, weather station, anything we don't need to update. Okay. We just need to create a new display device via implementing this observer. So that is very easy, and this is following our SRP, OCP, and all the solid principles also. So that's how we implement the observer pattern. So we have implemented the observer pattern. Now let's see how it works internally. What is saying like this observer subscribes to a okay subject. Okay, the subject stores the observer information. Then the state changes. Okay, and then it calls the notify observers method, and this update triggers on the all observers. They need to implement the update method by their own. Okay, let's say if a mobile will have the separate algorithm to update the temperature. Okay, and the another thing will have the another type of update method. So benefits of the observer pattern that we have seen, like it provides the loose coupling, it provides the scalability, runtime subscription, flexible architecture, cleaner code, supports event-driven systems. Event-driven systems like you see in the Kafka, RabbitMQ, these are all based on the observer pattern. Real world applications that you see, okay, GUI event listeners. Okay, when you do something and the state updates everywhere, let's say, correct? And stock market apps, like stock market apps are also based on the observer pattern. Price of the stock changes, then all the devices will have show the correct price, correct? Then social media notifications, news subscription systems, logging frameworks, and YouTube subscribers. These all are the based on the observer pattern. Pub sub analogy or publisher subscriber analogy. Publisher will publish a message broker, then subscriber. Observer pattern is the foundation of these things. Kafka, RabbitMQ, and event-driven architecture. The publisher will publish a message to the So, okay, let's say publisher is publishing a file. Okay, then the message broker will uh, transfer it to the subscribers, all the subscribers. Let's this Kafka, RabbitMQ, and event driven arc, and all these things happen via this observer pattern only. Pros and cons, let's see. The advantages, as we see, the decoupled architecture, reusable observers, dynamic relationships, and disadvantages like we need to uh, handle too many notifications. It is hard to debug who is subscribed or not. Okay, and the possible memory leaks also can be a case. These are the interview questions that you can go through, differences between the observer pattern and PubSub. Where is the observer used in Java? Why it is a behavioral pattern? How does event handling and use observer? These are based on this video only, and you can go through the video again, and okay, you can prepare these questions. So this is the quick summary. This observer pattern, what it is saying, like it creates one-to-many dependency, notifies all the observers automatically, reduces type coupling, and widely used in the event systems. Key takeaway, you can remember this line, okay? Subjects publish updates and observers create. So all right, guys, we have implemented the observer pattern in a very good way, okay? And I hope you loved this video. And in the next video we will see the another behavioral pattern. Okay, so yeah, that's all for this video, guys. And if you haven't checked out this series, LLD series, then you can check out my channel. Okay, and you can go through all the series, and in this series we will implement all the LLD principles. Okay, so this is going to be a full low level design course. Okay, you can go through the playlist. Thank you so much, guys, for watching this video. I will see you in the next one.